This video covers the review for section 11.1. Composition of two functions. Suppose that f of x is x squared minus 4x plus 5 and g of x is 6x minus 5. Find the composition of f with g, or f composed with g. The order on this one is g goes inside of f. The order in B is f goes inside G. And so if we put G into f, G is 6x minus 5. Putting this in to f says we need to take and put it where we see x. So we need to square it. We need to subtract 4 times it, and then add 5 to that result. We're putting 6x minus 5 in for x in f of x. So we have 6x minus 5 squared minus 4 times 6x minus 5 plus 5. 6x minus 5 squared, we have to FOIL that, which gives us 36x squared minus 30, which is minus 60, plus 25. Then we have minus 24x plus 20 plus 5. This gives us 30x squared. Minus 60 minus 24 is minus 84. 25 plus 20 is 45, plus 5 is 50. 30x squared minus 84x plus 50. If we go in the other order, where we put f of x into g, f of x is x squared minus 4x plus 5, and we're putting that into g. And g takes its inputs, multiplies them by 6, and then subtracts 5. We're putting in x squared minus 4x plus 5. This gives us 6x squared minus 24x plus 30 minus 5, which is 6x squared minus 24x plus 25. So in summary, composition of functions is putting one function into another function. Number 2, determine if the following functions are one-to-one. Recall that a one-to-one function states that each output corresponds to only one input. And when you look at letter A, the output of 3 corresponds to 2. The output of negative 5 corresponds to 4, but it also corresponds to 6. That's the problem. That output of negative 5 corresponds to 2 inputs, so this is not one-to-one. It is a function, but it's not one-to-one. So we're on the lookout for repeated y values. 2 goes to 3, 4 goes to 5, 6 goes to 10, and 8 goes to 16. This one's one-to-one because 2 goes with 3 and 3 goes back to 2. In A, we don't know where 5 goes back to. It has 2 different numbers. This is one-to-one. Number 3, the graph of a one-to-one function is shown. Draw the graph of its inverse and the line y equal x on the same axes. Note, this graph does not touch the line y equal to negative 3. So recall, if the point xy is on the graph of f of x, then the point y comma x is on the graph of the inverse. So to form or to graph the inverse of this function, we go ahead and swap the ordered pairs. Negative 2.875 goes with negative 3. Negative 2.75 goes with negative 2. Negative 2.5 goes with negative 1. Negative 2 goes with 0. Negative 1, 1. And 1, 2, and 3, 5. So if we graph these, negative 2.875, 1, 2, 3. Negative 2.75, negative 2. Negative 2.5, negative 1. Negative 2, 0. Negative 1, 1. 1, 2. And 5, 3. So when we graph this, since the function f of x didn't touch the line y equal negative 3, the inverse function does not touch the line x equals negative 3. It continues to increase here, but slowly. Now we draw the line y equal x to show that each graph is a reflection of the other about that line. Finding inverses by the switch and solve method. We have this as a procedure. The switch and solve method. Step 1 is to write the y back into the problem. Step 2 is the actual switch. Interchange the variables x and y, so we have x equals cubed root of y plus 4 minus 5. We have formed the inverse function, but now we need to solve for y to write it in function notation. So we solve for y. We do this by adding 5 to both sides. And now we have to get that y by itself. So to undo a cubed root, we cube both sides. The cube of a cube root undoes it. We have y plus 4 equals x plus 5 cubed. And so then we subtract 4 from both sides to get y by itself. And we say x plus 5 cubed minus 4. Step 4 is just formality. We found the inverse function, so we say f inverse is x plus 5 cubed minus 4. Now, if you want to be sure that this is your answer or the correct answer, you can verify this by putting f of x into the inverse function and making sure you get x, and then put the inverse function into the function to make sure you get x. And so there's our inverse function. Notice how we started with a cubing function, cube rooting function, and our inverse was a cubing. We always know that the cubed root of something is the opposite of cubing. Number 5 is a rational function. Find the inverse of f of x equals x over x plus 5 by the switch and solve method. Step 1, we write the y back into the problem. Y equals x over x plus 5. Step 2, we switch the variables and write a y where we see an x. Step 3, we solve for y. To solve for y, we're going to multiply both sides by y plus 5. We multiply both sides by y plus 5, and that clears the y plus 5, and we have y equals x times y plus 5. So we distribute the x across. Now we want to solve for y. Whenever we solve for a specific variable, we get all of those terms with that variable on one side and all the terms that don't have it on the other side. So I'm going to subtract yx from both sides to get all the y's on the right side. And all the terms that don't have a y on the other side. Now we have to combine y here. We have to get y by itself. And the way to achieve that is by factoring out a y from both terms. When you take a y from a y, you're left with 1, and a y from a yx, you're left with x, or minus x. To solve for y, we divide both sides by 1 minus x. And now we've got y all by itself, 5x over 1 minus x. Last step is the formality part of this. We found the inverse of f, which is 5x over 1 minus x. And this concludes the video for the review for section 11.1.